Okay, we're back in Mr. Chem's lab, and today we're going to take a look at mercury. Mercury is a fascinating element, and a lot of students are never actually going to be able to see some of these demonstrations that I used to do years ago because of its toxicity. It's been eradicated in a lot of public school chemistry labs. Now, but unfortunately, there's nothing that I have found that better demonstrates certain concepts, density in particular, than mercury. For starters, while it's still in the jar, what I used to do is have some students, it was double bagged, triple bagged even, students kind of give it a feel, and it's incredibly more dense or more heavy than they would expect something this size to be due to its density. Corbin, which you don't have to take my word for it. Why don't you take someone else's word for it?
Super heavy.
See, what did I tell you? Another interesting property of mercury is its cohesiveness. This is also what makes it extremely hard to clean up a mercury spill. I'm going to just place a little bit in this beaker, and hopefully, if Brittany can zero in on it, you can see that it's more cohesive than water, quite a bit more. It forms these cohesive, meaning one mercury atom wants to be around other mercury atoms, and they cling to each other. And as a result of that, when you break a mercury thermometer or have a mercury spill of any kind, it forms just thousands of tiny little balls of mercury. And what do balls do when they hit the floor?
Roll.
They roll. That was Corbin again. They roll. And you've got these thousands of tiny little mercury balls scattering in every direction. And this makes mercury spills extremely hard to clean. You'll never get it all up. Now, another interesting property of mercury that I didn't really take the time to mention is it's one of the only elements it's one of very few elements that's a liquid at room temperature. And it's the only metal that's a liquid at room temperature. The cohesiveness that we just discussed is not only what makes mercury spills extremely hard to completely clean up, but it's also what makes it so much fun to play with for kids. When I was a youngster in science lab, I remember breaking mercury thermometers, not intentionally, but when they would break, we would all just love playing with the little balls of mercury. Because like I said, there's nothing else quite like it. Now this is what really drives the density point home too. I poured the mercury into a beaker. Well, you saw that already. I didn't need to say it, did I? I've got a steel ball here. Just to show you, it's not one of those phony steel balls. And we're going to place it in the mercury. And how many liquids can you think of that steel balls will float on? Not many, I bet. And this isn't just an illusion. I'm trying to push it down. Sink. Sink, you steel ball. It's not sinking. This ought to sink, right? It's lead. It's a lead sinker. But the lead sinker isn't doing what it's made to do. Not in mercury. But fortunately, we don't fish in mercury. And there you have it. I'm trying to think of something else to say, but nothing's really coming to mind. So with that,